Good morning. Today we're going to do our best to analyze data to determine the effect rigidity has on elastic energy. So let's review some terms now. We have elastic energy. Elastic energy is associated with the deformation of an object by compressing it or stretching it. So stretching or compressing, and then its ability to go back to its original shape. Deformation is just the action of changing the shape when you're adding pressure, and then the elasticity part is it being able to go back to its original shape. How quickly can it go back to its original shape, or does it kind of linger and kind of morph back slowly? All right, rigidity is the measure of how hard an object is and how resistant it is to being deformed. So I have a few balls here. So how hard it is and how resistant it is to being deformed. This is pretty easy to deform, but not so rigid, right? And we have a bouncy ball. It's even very hard, okay? That's why it's called a bouncy ball, right? Very rigid. And we have the racquetball that you've seen, I think, a couple times now. It's kind of not as squishy as this, but definitely not as hard as that. Still a little easier to compress. And then we have a marble. Yeah. Really hard, really rigid. So kind of think to yourself, if I was to bounce all of these, which one, the marble's in here, you can't really see it, which one would bounce the highest? Okay, and I'm not going to do this demonstration because it's kind of hard to do, not in the classroom. But I mean, let's say this one, we know, yeah, it'll bounce because it can be deformed and it can go back to its original shape. It's not going to bounce very high. And then the marble, it's kind of the opposite side of the spectrum here. Here we have really squishy, it's not going to bounce really high. And here we have really hard. Is it almost too hard where, you know, you're going to have some bounce still? See, it did bounce, but is it almost so rigid, too rigid, that it really can't bounce that much? And then you have kind of two that are in between. That are kind of getting, you have some rigidity, but it's able to compress a little bit. This one even more. Okay, this is a super bouncy ball. This one's going to go really high because it's pretty rigid, but it's still, you can still squish it a little bit, right? And then there's the matter of what the material that the ball is made out of, and so on. So today, I'm going to do a demonstration of a lab where we're going to use 3 different types of rulers. Okay, and we're going to fling a paper ball and see how high we can get it to go. So I want you, I'm just going to get my paper ball as well. Hold on a second. Okay, so here's my paper ball. Do you remember the lab where we made the tinfoil ball into the cupric chloride and we barely made the ball? We made it really loose. This time we did the opposite, where we really wanted a tight ball. So here we go. Nice paper ball here. And then I'm going to be flinging it with 3 different rulers. So here I have ruler number 1. It's clear. And this is how rigid it is. Then we have ruler number 2, it's green one. And then I have ruler number 3, it's wooden one. All right, so you're going to make 2 predictions now. One, which ruler is more rigid and which one's less? So we have the wooden one, green one, clear one. Okay, so answer that question. And then next, which of these 3 do you think will make the paper ball go furthest? The wooden one, the middle one, the green one, or this really flimsy one, the clear one? All right, so answer those 2 prediction questions. And if that took you 20 minutes, you can be done for the day and watch the experiment tomorrow and answer those questions, or you can go on and do that today as well if you'd like. Good luck.